Now come to carbon molecule. Carbon has 6 electrons, 1s2, 2s2, 2p2. In this molecular orbital diagram, what we have seen, this is for a single carbon atom, this is for another carbon atom, this is our energy level, and this is the C2 molecule where linear combination of orbital waves would take place. Carbon has a configuration of 1s2, 2s2 and 2p2. So let's fill this for one carbon. This is how the configuration is filled. For the second carbon also 1s, the same energy level, 2s, the electrons, and 2p. As I said, for 1s and 1s atomic orbitals, we will have one bonding and one anti-bonding sigma orbitals named as sigma 1s and sigma star 1s. For 2s atomic orbitals also, we will have two molecular orbital. One will be bonding, another is anti-bonding, shown by the energy diagram. So the lower one is known as sigma 2s and the higher energy is sigma star 2s. That's how these orbitals are being formed. After that, we will have the pi to px, pi to py. Then we will have lower level sigma to pz, and anti-bonding also we will have pi star to py, x pi star to py, degenerate set, and sigma star to pz. The orbitals are filled up like this. Total number of electrons in one carbon is 6. Then in C2, the total number of electron in C2 molecule is 12. 12 electrons are finally filled as 2 to 4 to 6 to 8, 9, 10. First single would fill up as per Hund's rule. After that, pairing would take place. So the molecular orbital configuration of carbon is that would be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. After that, pi to px, pi to py, 2 and 2. First 1, then after that plus 1 and plus 1. So we have 12 electrons filled up like this. And this, after filling up of this electrons, we have this configuration. The bond order will be half into total number of electrons in bonding molecular orbital. Out of this, only these two are anti-bonding molecular orbitals. So we have 2, 2, 2 and 2, 8 bonding molecular orbital electron and 4 anti-bonding molecular orbital electron. The bond order is equal to 2. That is, in C2 we have an average of bond strength of the double bond, and since it has no unpaired electron, it is diamagnetic in nature. Now when we will make the nitrogen molecule, it's obvious that in nitrogen molecule we will have 7 nitrogen, 1s2, 2s2, 2p3. Now students will follow this, as I am not writing the nitrogen, but from here you have to make nitrogen by your own. What I said, that this will be 7 nitrogen, 1s2, 2s2, 2p3. In this a single, this will be nitrogen atom, this will be also nitrogen atom, this is N2 molecule and linear combination of atomic orbital. Unlike this carbon, you will have 1s2, 2s2 and 2p3. So all these 3 electrons would be there, here also 3 electrons would be there. That means in one nitrogen we will have 14 electrons. In this 14 electrons, now this 14 electrons would be filled up as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi to px2, pi to py2 and sigma to pz2. Up till all these bonding molecular orbital, this 14 electrons would be filled. Then in this case, I am writing just the molecular orbital configuration of nitrogen. This will be sigma 1s2, sigma star 1s2, that is anti-bonding, sigma 2s2, sigma star 2s2, pi to px2, pi to py2, sigma to pz2, and all anti-bonding orbitals would remain, with a sigma or pi would remain vacant. So we will have the arrangement like this. See how I am filling the electrons according to Hund's rule. These 2 are anti-bonding electrons. Therefore, the bond order would be half into total number of bonded electrons are 2 to 4, 2 and 2, 8 and 2, 10, minus anti-bonding electrons are 4. That is, the bond order is 3, which clearly indicates that nitrogen is having a strength of triple bond in between 2 nitrogen atom, and that's how dinitrogen is very stable and chemically less reactive. Now just consider in air we have almost 79%, more than 78% of nitrogen and a highly reactive species oxygen, but then too in air or atmosphere this nitrogen and oxygen do not combine with each other. That is only because of the poor reactivity or inert nature of nitrogen. That is the reason why nitrogen is also known as azote. AZOTE stands for lifeless, means which dilutes the effect of oxygen. And you could recall that only during lightning and thunder this atmospheric nitrogen combines with oxygen. In presence of electric spark above 2500 degrees Celsius, that is near about 3000 degrees Celsius in the higher altitude, to form that during that lightning or thunder only it forms nitric oxide NO, which finally changes to NO2, nitrogen dioxide, and finally when dissolved in water or the clouds in presence of oxygen changes to acid rain, the nitric acid. So rarely this atmospheric nitrogen combines with oxygen only under certain condition of very high temperature, which indicates that it has a very strong bond dissociation enthalpy. Bond dissociation enthalpy larger means it has a highest bond order, and the highest possible bond order is 3. So this is supported by this molecular orbital theory too.